Welcome to episode 3. Today we're going of our IPv4 course. We're going to look at the different types of IPv4 addresses. So this is actually the different type of addresses that we've got to work with, we'll look into that now. Let me just jump into my different desktop. So yeah, different types of IPv4 addresses. So the concept is very unique here. When we're going to IPv6, when we do that class, it's going to be different than this. But there are different classes that we've got to work with. All right, so let's get into it. So now, back when IPv4 was invented, something that we need to understand is in that particular time, they were trying to solve a problem in those times. They would have maybe 3 or 4 computers in a whole building back in the 70s. There weren't that many computers around then, and they used to have these big floppy disks. They would save information, and then they would walk. It used to be called sneakernet. Sneakers is in runners or sports shoes. They would run around and save to another computer. You'd have printers. Every computer pretty much had their own computer. So they created these ways of networking these several computers together. An organization got together and created the RFC 1918 protocol, or you can Google this. It's the most popular RFC, request for comments. I think that's I've only looked at them. I've never read one. I prefer to read textbooks and learn from instructors than instead of going to these documents, because they're not that beautiful. So I might show you one really quickly. As you can see, it's not the most elegant or attractive or amazing thing out there, but it's very useful that so that when developers, when organizations, when electrical companies or computer IT companies get together, they've got a place to go to that they can agree upon standards. One of the things that they wanted to agree with or work out was something called a class network. Now it should be here somewhere, yeah. With a more particular private addressed space. Now look, if you want, come to this website. It's just type in RFC 1918. It'll take you right here, and you can read a little bit more about it. But these are the addresses that we're looking for, the private address space. We're going to talk about that very, very shortly. So yeah, it's an interesting document, but it's not a very beautiful document. It can be hard to read. But I do know some people who love this kind of thing. So let's build the story a little bit further. So now these 70s organizations got together and created an RFC 1918. Okay, they said, oh, here's the rules. So at the time they thought, well, let's create something called Internet Protocol version 4, because the networks were starting to get bigger. There were more computers, and not only in buildings but outside buildings as well, between different geographical locations. So it's starting to get a bit bigger. The American Defense Force, DoD, they call it Department of Defense in the US. Then they've got the universities, and the banks got on board, financial institutions, schools, high schools. So all of a sudden this network's getting bigger. So they were using IPv4 pretty much everywhere for a very long time. There were other protocols too. There was AppleTalk. There was another one which I can't remember. It escapes me. But IPX, I think they call it IPX. So everyone was using IPv4, most organizations, but they realized that they've got some problems. And one of the biggest problems is that they were running out of space. Now, when they designed this, they thought there is something like 4 million, we'll get the exact number in a second, about 4 million IP version 4 addresses. Okay, we have 4 million of them. Now, at the time in the 70s and 80s, they're like, well, there's only like a couple of 100,000 computers out there in the world. There's maybe 1 million, maybe 2 million, but they're not all of them are going to be connected to the internet. Well, they realized by the 90s, when the internet took off, when the web took off, that they were going to exhaust that very quickly. And just for record, for those who are interested, we've run out of IP version 4. In most, I think Africa, they might have a few left floating around, but they're pretty much all gone. We've got IP version 6, which is going to help us, but they invented a couple of very, very clever ideas to lengthen IP version 4's survival. Now, by the way, there is version 1, 2, 3, and there is a 5, but what happened is they kept making mistakes and they couldn't agree with it. So 1, 2, and 3 just disappeared. And IP version 5, it disappeared too. They thought, instead of fixing IP version 5, the mistakes, we're just going to make IP version 6. So they exist. They were in the process of being created, but they didn't make it. So instead of going back and fixing it, they just decided to start again. And sometimes, you know what, if you're building a building and a tall tower or a bridge and the foundation's wrong, sometimes you just have to pull it down and start again. That's what they did with IP version 5, for example. All right, so one of the clever things that they did in order to save or to extend the life of IP version 4, to a point, there are different strategies. We're going to be with IP version 4 for a long time, a very long time. When I first did my Cisco class in the late 90s, they taught us about IP version 6, and they said that in 5 years' time we'll have to move to it. Well, this is 20 years later, 23 years later, we're still using IP version 4. IP version 6 is actually extending the longevity of IP version 4. It's really, really interesting. They kind of complement each other. It's like radio versus television. They said that radio was dead, but people forgot that when you're driving to work, you have to listen to the radio, and so it'd still be around for a long time. But one thing that did save IP version 4 is the concept of public, and we'll talk about classes shortly, but we're going to talk about public and private IP version 4 addresses. Public and private. So what the idea was that when IP version 4 first came out, every PC will have unique IP version 4 address. Okay? That was the idea, that was the plan, but that didn't last long. That was dead as soon as it was, as soon as it got going, it was already dead, it was already doomed. So what they came up with instead, okay, is that saying, okay, well, we can't do that anymore. How about we do this? Let's reserve a portion of all available IP version 4 addresses, for private use only. How about that? For private use only. But they have to be isolated on the networks they've been assigned on. I cannot use these for public computers or hosts or servers. They cannot be routed on the internet. In fact, your ISP, if you're with Telstra, Optus, or TPG, or Aussie Broadband, or if you're somewhere else around the world, whatever your internet service providers are, they've got on their routers, and they'll probably be using Cisco routers. They will have it that they're going to block private addresses, so you can't even attempt. Okay, but you can use it within your own house or your own organization, your own office, as much as you like. You can use it, and you don't have to pay for it. It's absolutely free, and you can use it any way you like. Okay, so let me give you those ranges. Now, we haven't really talked about the classes of IP addresses yet. We will go through them later on. We're just sort of like building stage by stage, because it's a big jump. Like IP addresses, learning about IPv4 is, for me personally, was probably the most hardest part about learning computer, IT networking, and I could not pass my CCNA without knowing IPv4. It's a challenging topic, no doubt. So we've got to build this bit by bit. So first of all, let's look at the private addresses. Okay, private addresses. We will get to classes next, probably next. So the first private address range, 10.0.0 and /8. Remember what that was? 8. So that means the first 8 bits as the network portion. So that's remember there's 8 octets there. Octets. So this is network, and that's host. That's a lot of hosts. That's 3 billion or something like that. I don't know. Maybe we should look it up somehow. But that's a lot of hosts, and not that many networks. Not that many networks at all. But if you wanted to, what you could do is you could get these private addresses and do subnetting, and do variable length subnetting as well. So you could use this massive, monumental, huge host, address here, and use it and break it down the way you liked. So you'd have in your organization. Remember, private organizations would use this, and use it any way you like. And we're going to be doing a lot of exercises in later in another episode, like heaps of exercises. But let me show you what that means. So I've got my I've got a network here. I've got an office, right? So I'm going to use this network /8. I've got the internet. So if I'm at home, okay, my head's in the way again. I'm going to use another private address, which we'll show you in a second what that is. Say .1, and it's a /24. So these are both private addresses. This is private as well. Can I send a message to that IP address? Absolutely not. There are millions and millions and millions of IP addresses exactly the same everywhere. I've got one like this. You probably have one on your computer right now. And there's tens of thousands, hundreds of thousands of IP addresses that look like this. They're private. They're not routable over the internet. I cannot get to that address from here. What happens is that Telstra or Optus or whichever ISP will negotiate with us at the office and give us a public IP address. And I'm just going to make something up. I don't know if this is an effective one. I'm not sure what this is. I'm just making this one up. This is a public address. On this side, Telstra, Optus, ISP, whatever, gives us, it's DHCP. They're going to give us some random, or not really random, but like we don't get to keep it, an IP address, a public IP address. It could be 9.7. I don't even know if this is a real one. I'm just making it up. But that's a public IP address. So to get to this office from home, right, I translate my private to public, and NAT is NAT network address translation is completely different topic. We won't go into it, but what's happening is our private address is being translated into a public address, which we can route. We can send a message to the office as a public address, which gets translated to private. Okay, so that's it in a nutshell, but let's have a look at those ranges. So the first range is 10.0.0, so that's /8. Then we have 172.16.0.0, which is 16, because that's the network. 8 plus 8 is 16. And finally, the most popular one, I'm sorry, my mistake. No, I'm right. Sorry. Scared me for a sec. And the last one is 24. Sorry, my note, I've got some slides here that are incorrect. I need to fix these slides. Yeah, sorry, just double checking. I'm just going to correct this very, very quickly. Let's just correct this. It's actually different than that, because we're looking at a range, and I'm looking at the different. I'm thinking about Class A, Class B, and Class C. But what we need to look at, and I apologize for this, instead of doing the whole video again, it's we'll go through this together. We'll fix this together. So this is the private address is different than Class A. I've got Class A, B, C in my mind at the moment. We're going to talk about that next, but it's just trying to get rid of. I should focus on something different. But the range here is from that to 10.255. So anything in this range, yeah. So from there to there is private. Okay. The next one is 172.16.0.0 all the way until 172.31.255.255. That's another private address range. Okay, so remember, these addresses are not publicly routable, only for private use. You could, if you want to, use any IP address you want within that range on your home network. What you can't do is get another IP address that's out there on the internet unless you pay for it. And they're very expensive, so I probably wouldn't worry about getting one. And then finally, 192.168.0 until 192.168.255.255. So you can use these as private address. Almost all other IP addresses, almost all others. Okay, some exceptions. You can use on the internet, but these are private. These ones you can use right now. No, you don't need to ask anyone's permission. You can just go ahead and take it for your personal use. All right. So we talked a little bit about NAT. I think we'll talk a little bit more about NAT. Okay, just not too in depth. Okay. So I've got my private address here, 192.168.5.6. I've got my little PC here, little computer. By the way, this recording, I thought it was only going to be 10 minutes. It's looking like it's going to be a bit longer. So if you need to get a coffee or something, press pause and come back. But anyway, we've got a router here, and that's going to the internet. Okay. So we've got that internet here. And then to another computer over here, another router, another home network, and I've got another computer, 5.6, with exactly the same IP address. Okay, but what's happening here is that our public IP address is different. Maybe it's 7. I'm just making this up, don't worry, it's not real. This one is 6.6.6. So what happens is this, in a very basic level, is we're going to translate this private. So let's translate. What do translators do? If you're speaking a language like maybe Chinese and you want to translate it to Spanish, you have someone in the middle that can interpret, that can speak both languages. This is what this is. This is network address translating. I'm going to translate private to public. So this IP address gets translated into that. And on this side, that gets translated to that. So when we're routing over the internet, remember there's like thousands and thousands of routers out there. Yeah? They'll be routing based on that. Telstra, Optus, ISPs have paid lots of money for this public IP address. They're giving it to you for a certain amount of time. On our routers here, our home router, it's doing the translation for us. It's using a NAT table. Now, technically, it's actually PAT that we're using now, but a topic for another time. So that's a little bit more in depth for that. I really want to get into the classes, but one more, almost there. All right. Now, there are some special IP addresses. Remember I said you can't use all of them. You have your private, public, but there are some you can't use. This one you can't use, ever. This one's reserved, 127.0.8. So this range here, this particular range, you can't use, ever. Won't work. Every Mac, Linux, Windows machine, Android, Apple, whatever device out there, you could never use this as an IP address. And in particular, this IP address, which is called a loopback. So what this loopback address, is it's testing itself. It's making sure that the protocol stack is working fine. So it's saying that, is my network card operational? Can I send it and then back to myself? Will that work? Okay. And if it does, that means my protocol is okay. My software is okay. Windows 10 is okay. Linux, Ubuntu is okay. Mac OS 10, blah, blah, blah. It's okay. Must be something wrong with my hardware or the network. That's loopback. The next one is a link local address. Well, I don't call it link local. I have another name for it. I call it an IPV4 address. IPV4. I can't even spell the word. IPV4 address, but they call it link local now. They call it link local because IP version 6 has come along, and they use this technology for IP version 6 as well. What it does, and there's something very, very important you need to know. Windows 10. When you load Windows 10, it must have an IP address, and it searches for it. It goes, if you don't statically define it, it's going to try and find one DHCP. The DHCP server gives that computer an IP address. Okay, it gives it. The computer asks, it sends out a broadcast. Remember broadcast from the last episode? Help, I need an IP address. Can someone give me one? So the DHCP server says, yeah, I can give you one. No problems, here you go. But what if there is no DHCP server? Well, Windows 10 will say, I can't DHCP. No, not there. Can't do it. So I'm going to create my own link local address, and it's always going to start with 169.254.0.0, and that'll be like a 1, 2, 3, whatever. It'll go all the way to 169.254.255.254. So that's the range for this special use. So what will happen is you might have 20 computers that can't get DHCP. They'll all randomly generate their own link local address, or IPV4, I like to call it IPV4. And the likelihood of them choosing the same one is very low, but if they did, they can work it out. And there can be connectivity between them. Very limited connectivity, by the way. And again, my big head's in the way. So there's limited connectivity between those PCs, right? But they can communicate. They can get it done. In IP version 6, it's more sophisticated than IP version 4. Something that's superior for IP version 6. You actually, technically in IP version 6, you don't even need a DHCP server. You don't actually, you can have one if you want, but link local is so effective in IP version 6. IP version 4, you can work. Okay, you can work, but there are limitations. All right, now finally, I've been dying to get to this part. I've been like, I can't wait to get to classes. I can't wait to get to classes. And let's go into it. So we've got different classes. Now the reason why we have different classes, it's just to let us know. It's classifying, sort of like, yeah, let me show you. Class C. We'll go to Class C. They're the most popular ones. They're saying to us that these addresses here, starting from there, 0.0.0.0, until 127.0.0.0, that's a Class A address. That's a class. So this becomes a class full address. Class full. Write that down or put it into your mind palace or mind map or whatever for another day when we talk about class less addressing. This is a class full. So just put that away in your memory somewhere. So that's saying to us that anything with the 8 bit, the first octet or ones, that's belongs to class A. It helps us break things down for us to make it easy for us to understand as people. So someone's saying, all right, give me a class C address. I know straight away that if I choose something from this range here, 192.0.0.024, sorry, all the way to 192.0. Sorry, getting ahead of myself here. 223.255.255.0. That's a Class C address. So I can choose that for Class C. Class B is, don't know why I've done it this way. Oops. Let me just, try to see if I can get, no, not going to work. I know most instructors have these already, but what I'm trying to do is I'm trying to to do this step by step and show you along the way. I don't want to have anything prepared. I want this to be live and unedited, so we can like go on this journey together. I know that there's an organization, instructors out there that are brilliant and amazing. I've been to many of myself, but what they lack is, you know, a bit of authenticity. And I'm trying to be a little bit authentic here. That's a Class B. And Class C is 192.0.0.024. There we go. So a lot of my videos I actually do things and things always go wrong, which is a great learning moment. You know, we can learn together how to fix that. So that's Class C. So that tells me if it's a Class C, then I know what range I can work with. It's just something for us to look at, you know, can you give me a Class C address? I know that a Class C is going to have not that many hosts, but lots and lots and lots and lots and lots of networks. I can use a lot of networks, but not that many hosts. Class B is like in between, and Class A means I'll give me a range, give me an IP address that I can work with that has just one or two IP addresses, network, but lots and lots of hosts. So yeah, it's sort of like kind of, you know, break things up a bit. Now there is Class D that we don't use that often. This is for multicast. Remember multicast we talked about in the previous episode? And that one is so multicast. So we've got a different weird address here. Quite strange. It's 224.0.0.0 to 239.0.0.0. So this is the multicast. Remember that multicast that we did in the previous episode, where you had 4 different computers that had an option of receiving the communication or not? Yeah, they're going to use these type of addresses. When we get down the track, maybe in a little bit later on, we quite possibly would look into multicast a bit more. But multicast is definitely a CCNP level. Again, it's really interesting. A lot of theory involved, but a lot of fun. Then, lucky last. This is mysterious. This is an X-Files kind of thing, or it's Class E. Class E, which is reserved for research purposes. Whatever that means. It's a bit, you know, no one really knows what they do with this until 255.0.0.0. So this one here, this research purpose, whatever that means. I think there's even another class, I think, that the military use. But in any case, with that at our level, at CCNA, we don't have to focus too much on it. All right, so the last topic before we finish, and this 10 minutes has turned into 35 minutes. One more thing is in regards to who actually gives the public IP addresses out. Who owns the rights? No one really owns it, but there's an organization called IANA, and it's the Internet Assigned Numbers Authority. They manage and allocate blocks of IP addresses. Okay, now they'll allocate it to 5 RIRs. Okay, and they're from this Asia Pacific, APNIC, Asia Pacific, so that's Australia, New Zealand, Indonesia, Asia, China, India. Then there's Europe, Europe/Russia, and a lot of the Central Asian countries, you know, Iran, Uzbekistan, Saudi Arabia, those kind of countries, and then all of Europe. Then there's Africa, which is AfriNIC, I think. Then South America, which includes Mexico, and then ARAN, which is the big one, US, Canada. So these RIRs, like in Australia, we use the Asia Pacific NIC. They get a block from IANA, and then they give it to the local, like in Australia, Telstra and Optus will ask for IP address blocks. Now they've all run out, so you can't go and get one now, but you can get some IP version 6 addresses if you want. Okay, so that's about it. If we've all done for that. Again, 10 minutes turned into 35 minutes, and I'm still going on. So we'll leave it at that. The next lesson will be a network segmentation. Then later on, we'll do some subnetting, and we'll do some other kind of really cool stuff later on. But until then, thank you for watching, and we'll see you shortly. Have a great evening or morning or day or weekend, whatever it is. Take care.